Yeah, hi everyone. So today let us try to discuss one very important concept from electrostatics. So actually, this concept is not there for JE. Okay, JE Advanced is not there, but it will be very much helpful for like Olympiad exams, like for NSEP and IPHO and all these exams. But so by knowing this concept, you might get a little edge in better understanding of this chapter electrostatics. Not, I won't say it's like necessary, but knowing it, okay, like obviously it will give some positive edge or like some added advantage in better understanding of the chapter electrostatics. Okay, so as I said, it's not there for JE Advanced, but okay, so it's a very interesting topic. So let us try to discuss this topic. Okay. So the today's topic that we are going to discuss is about uniqueness theorem and like method of images. Okay, so let us try to understand what is this uniqueness theorem and what is this method of images. So let's say there are some charges in the space randomly arranged like this. So I am taking like some 6 charges I took over here. So let's say this is Q1, this is Q2, let's say this is Q3, this is Q4, this is Q5, and this is Q6. Okay, so in this entire space, wherever I am asking, let's say, to calculate some particular parameter, it might be a potential or it might be a field. So basically you just need to find if it is an electric field, you need to take vector sum of like what electric field due to each and every charge or at that point. So then you're going to get the resultant electric field. And let's say if I'm asking potential due to all this system of charges, then again you will be just trying to find potential due to each point charge. Okay, and then you'll just add as a potential is a scalar quantity, you'll just take the scalar sum of all those things and you'll get the net potential. Okay, so now, but like what does this uniqueness theorem state means? Let's say because of all these charges, whatever the system of charges that we are having here, let's say there is some equipotential surface. Okay, so I am just drawing, let's say there might exist some equipotential surface randomly like this. Let's say this is an equipotential surface, and of some potential V0. Okay, let us take some potential V0. What does that mean? That means if I find the potential due to like all these charges or this whatever the surface that I took, okay, wherever I find the potential, it will be like equal to what? It will be equal to the V0 potential. So like we are able to find some equipotential surface for this given system of particles, and as I said that for a particular voltage V0, okay, this would be the equipotential surface, and there might be some other voltage for which you might get some other different equipotential surface. But as I said, for the V0 potential, okay, for the V0 potential, so this is the locus of like basically the locus of all the points which are having V0 potential will gives us some surface which we name it as the equipotential surface, because each and every point of that surface got what, like equal potential of V0. Okay, so now what does this uniqueness theorem says means? Okay, let us try to understand what does this uniqueness theorem says. Now I'll try to like add some conductor over here. Let's say I'm trying to add some conductor over here, and we know conductor is a what, equipotential surface. So conductor should be on what, equipotential surface. So basically the green line is the imaginary surface. Okay, there is no material is present over there, but now I am constructing an imaginary conductor. Let's say there is a conductor just outside the equipotential surface, whatever that is there. Okay, basically the conductor is over here, this part. Now what I am telling is like what does this uniqueness theorem state means? There exists a conductor. Okay, there exists a conductor, and whose potential can become what, V0. So how its potential can become V0? So just because of these charges it is not possible. Okay, so that means there should be some charge or what, there should be some charge over this conductor. So let's say imagine there is a Q charge okay, that should be there on the conductor, such that the potential due to this conductor of charge q, okay, and this q6 q4 q5 q6 must have an what potential of v naught. Okay, so again try to understand this carefully. So I am constructing a conductor which is just outside the equipotential surface, whatever that is there, and I am telling that we should be giving some charge q to it in such a way that whatever the conductor that I have constructed, that conductor got the same potential as the equipotential surface, whatever it is there. Okay, and for that to happen, whatever this q is there, this q is going to distribute, okay, non-uniformly. So it is so obviously it should be what, non-uniform distribution. So it will be a non-uniform distribution, and ensuring what, so it will just ensure that the potential everywhere throughout this conductor, okay, anyway conductor is an equipotential surface, it will ensure that whatever the distribution is there, that distribution of charge will ensure that the potential of the conductor will become what, v naught. Now what does this uniqueness theorem states means, like earlier whatever the results that you used to get over here, that might be a net electric field or like net potential, whatever that is there because of all these 6 charges, now also we are going to get the same result after replacing these 3 charges with a conductor, okay, which is having a charge q. That is what the uniqueness theorem states. So why it is called unique means, so for this particular potential v naught, there is going to be a particular amount of charge that is fixed, which can create this kind of system. What kind of system? It is going to get same result of the original system. So basically we can say something like equivalent. We'll say equivalent resistance, equivalent capacitance, right? Similarly, I can say whatever the new system that I created is in what? Equivalent system to the original system. What is the original system? 6 point charges are there. Okay, that is our original system. Now what I am telling, there exists a unique, okay, like equipotential surface which I replaced with a conductor, okay, of a potential v naught, and to get this potential, this conductor should carry some amount of charge q, which is also again uniquely defined. The potential and the charge are like uniquely defined, ensuring what, ensuring the whatever the result that earlier we used to get outside this conductor, that might be a field or potential, it will remain same. Okay, it remains same. And now let us try to find that what is the value of q then. So let us try to understand what is the value of q. So how to find this q? So as we know, let's say this is the conductor body. If I consider a Gaussian surface over here, I know inside Gaussian surface like net charge should be what? Inside Gaussian surface net charge should be like net electric field should be 0. So if net electric field is 0, inside a conductor, inside a conductor we know that inside a conductor body electric field is 0. So if I find flux integral E bar dot ds bar closed integral, which is equal to Qn by epsilon naught, so what we should get? We should be getting this as a electric field everywhere inside the conductor is 0. We should get total flux should be what? 0. So for that net charge inside should be 0. That means whatever the charge that is over there here, negative charge should be there. Okay, that means like minus q1, minus q2, minus q3 should be there, and like just opposite to that the remaining charge should be over there, where the remaining charge should be present outside. That means, so basically simply speaking, the value of q is nothing but simply what? q1 plus q2 plus q3. So this will be the value of charge q. This will be the value of charge q. So this is the value of charge q, and charge is also like uniquely defined, as well as whatever the shape that is there, just similar to the equipotential surface only, we have constructed some conductor. Now as I said, we are going to get the same results, even though if you are finding the result due to just this conductor which is having a charge what? Q, which is completely non-uniformly distributed, and due to this q4, q5, q6, whatever point you take and find the field or like potential, you are going to get the same result as what? Whatever the result that you used to get by finding due to all these 6 charges that is there. Okay, and not only this way, vice versa is also possible. So what is vice versa? Vice versa is, let's say, imagine now already there exists a conductor. Okay, already we are having a what? Conductor. Let's say, imagine already we are having a conductor, and outside, let's say, there are like let's say two charges. Simply I'm taking two charges, Q1 and Q2. Now, like because of this, obviously there will be a charge into like charge induction on top of this one, right? So again, so there will be some charge induced on top of this. So ensuring that net charge will be zero. Okay, so because no initial charge is given to this conductor, so okay, like what? Ensuring net field inside the conductor zero, net field inside the conductor zero, or in other words I can tell, ensuring the conductor what? Equipotential. The charge is going to distribute. It's like zero charge only. The whatever the zero charge is there, now it can distribute in such a way that here negative charge can be there. Here some positive charge can be there with different densities, ensuring that field anywhere inside will be zero, and the potential of this entire conductor remains what? Same, and going to distribute non-uniformly. Distribute non-uniformly. Okay, so once it has distributed non-uniform manner, see now if I ask what is the electric field over here, okay, then it is very difficult for us to find. Okay, earlier it is easy because all are like point charges. Now it is like very difficult for us to find what is the electric field, because due to these 2 point charges I can find. But what about due to this conductor? Conductor I cannot find because it's not a just kind of some standard object like a sphere or cylinder, due to which I know the electric field, right? For a ring or disc, whatever it is, it's like completely like a random object, random conductor of random shape, and the charge distribution also. The main thing is charge distribution also completely random. So due to this I cannot find the field over here. But what does this uniqueness theorem says? Uniqueness theorem says there exists, okay, one more, like there exists a charge inside this. Let me take it as Q3. I don't know where that Q3 charge is there. Okay, so what I can tell here, very important point. There exists a charge Q3, okay, which will ensure that we are going to get an equipotential surface just same as the whatever the surface of the conductor is there. Okay, remember, like try to understand this. There exists a unique charge Q, okay, for which I am going to get it, like it can be a single charge or like multiple charges. That doesn't, okay. So what I am telling, it might not be a single charge. There exists a set of charge. It can be a single or it can be 2 charge or 3 charge, whatever that is there. But there will exist a unique setup, for which again I am going to get the same equipotential surface. Okay, there exists a unique setup of charges for which again I am going to get the same nature of equipotential surface of the equipotential surface as the conductor. Okay, conductor. And what will be the charge? Okay, I don't know what will be the charge, that we need to find. Okay, so we need to find that, but there will be some setup of charge for which again I am going to get the same, okay, same surface, same nature, like whatever the conductor surface is there, similar surface, you will be getting similar shape, which will have the equal potential everywhere. Okay, so then, sir, what is the conclusion with that? What is the conclusion we can say? The conclusion that we can say is, after finding, okay, so here I am writing, there exists a unique setup. There exists a unique setup of charges inside the conductor, ensuring we get similar equipotential surface as the conductor. What will ensure? Whatever the charge that is there, by keeping at the particular setup, it will ensure that I am going to get the similar equipotential surface as the what? Conductor. Then after that, what we can do, then, as I said, the equivalent system. Okay, it's like, what is the equivalent system? Earlier, I want to calculate what is the field or potential. Field or potential due to what? These 2 point charges and the conductor, where the charge is like non-uniformly distributed, right? But now I can, as I said, uniquely I can find this charge and set up, if I can find, okay, if I can find by doing some mathematical calculation. I don't know like what calculations, at this point of time I don't know what to, like how we can find and all that stuff. But let's say if you are able to find that uniquely defined setup, then simply it's a point charge, right? Now what I am telling, as I said, it's an equivalent system. We can easily find what is the electric field due to these point charges, right? And I can find what is the or else what is the potential due to this, or like what is the force between this. All this stuff I can find easily, because now it's a point charge. Earlier it is like an completely non-uniformly distributed, some kind of random object for which I cannot find anything, right? But now like easily I can find whatever the values that I want, right? So this is the just basic understanding of what is an uniqueness theorem. Okay, so still I haven't started what is method of image. This is the basic understanding of uniqueness theorem. Okay, so if you understand this, now let us try to solve some standard models which you could see in books, or sometimes you'll be able to find these type of questions in standard HCO, Irido book, or some AITS and all these papers. You will be able to find these standard questions. Okay, so let's try to discuss the first standard question that you will be able to solve from this uniqueness theorem. Okay, the first standard question that you will be able to see based on this concept is, they'll tell there is a point charge. Okay, they'll tell there is a point charge, and they'll tell there is a conductor. Okay, there is a conductor which is very close to it. They'll tell there is a conductor which is close to it, it's long conductor. They'll tell that means almost like infinite length, right? And they'll tell it is grounded. And then they'll be asking us to find what is the force between this conductor. What is the force between this conductor as well as it's grounded. Okay, this conductor is grounded. Now they'll be asking what is the force between this conductor and this point charge Q. So one thing you need to understand immediately, once this Q charge is there kept in front of this, obviously the charges will redistribute on top of this. Okay, the charges will be induced. Now I cannot say net charge on this one is 0. Okay, if this grounding is not there, then I say net charge will be 0, and they will be distributed in such a way that net electric field inside the conductor will be 0 and total charge is also 0. But once it is grounded, to ensure that the potential of the conductor is 0, any amount of charge can flow from ground to the conductor, or from the conductor to the ground. Anything can happen. Okay. Now after grounding, as I said, some random charge distribution can happen over here. Now they will be asking what is the interaction force between these two. Okay, or they might ask what is the energy stored in the system. So all these things they can ask. Okay. So now let us try to understand how to approach this type of questions. So obviously you need to understand that this one is a point charge is fine, but here this is not at all a point charge, or even though if you think it's an infinite, sheets are fine and everything, but here you need to understand it's not an uniform distribution. If it is a uniform distribution, again it's completely fine for you. If it's an infinite sheet, and if you know the charge, and simply I'll tell electric field due to this at any distance, irrespective of the distance, is what? If it is conductor, it is sigma by epsilon naught. If it is a sheet, it will be what? Sigma by 2 epsilon naught. Then you will say, sir, I know the field at that point, and I'll multiply the field with the charge, and I'll get the what? Force. So that's what you will be telling. But the problem here is, here the charge distribution is not uniform. Okay. Then what should be done? So here if you understand how the field lines will be there, the field lines, the field lines will always be what? will be perpendicular to, either they will start or like they will be end at the conductors perpendicular to the conductor, right? Something like this. Now, instead of solving this question directly, here I am going to approach in a different way. So what's the different way that I will follow? What's the thing that I am trying to follow is, now I will try to search a particular type of system or like particular type of charge setup which can ensure that the potential of this whatever the surface that is there, this is a conductor, right? But imagine now there is a surface over here. This surface should have a zero potential. So I hope like you can easily figure one setup very easily. So what is that setup? If I just take a symmetrical charge over here, just symmetrically if I take a charge but of opposite charge minus q, of like what? Opposite charge minus q, then obviously what will happen? So what will happen means then now whatever the electric field that is there, now here, sorry, if you take a minus q charge over here, now try to find the potential anywhere on this surface. If you try to find potential anywhere in the surface, obviously it will be zero. So why it will be zero? This is also plus q, then this is minus q, and as it is symmetrical to this one, like you take any point on this surface, it will be at the same distance for both the charges and they are like opposite charges, right? So basically it will be kq by r and plus k into minus q by r. So potential anywhere it will be what? Zero. So that means indirectly we are able to create this. Earlier actually there is a conductor and there is a charge. Now by using this one, okay, conductor is there, charges are there. Now I am going to use this analogy of converting this conductor into a what? Equivalent system, where I will remove the conductor and I will replace it with a what? A charge setup. So this is what I am trying to do now. I want to remove this conductor, but I shouldn't change any effect. What are the effects? I shouldn't change this electric field over here. I shouldn't change the potential at this surface. So I need to try to get that kind of setup. So here the potential will be zero only for this kind of this case, where I take equal charge, okay, equal amount of charge kept at the same distance, so that each and every point of that conductor, whatever it is taken, will be at equal distance from both the charges. So potential everywhere will be what? Zero. Not only equipotential, potential is zero because it is grounded. That's what is necessary, right? If it is not zero, if it is not grounded, then here we can have any charge. Okay, here we can have any charge, but obviously here what charge is there? Sorry, here it is grounded, so its potential must be zero. So for potential to be zero, so this is one setup, right? So I am taking a symmetrical charge, like same equivalent opposite charge, which is kept at the same distance from the same perpendicular distance from the plane. So that potential everywhere is what? Potential everywhere is becoming zero. Okay, now if you try to understand now the other sides and how the field lines will go. Now they will continue to here they will continue and they will be just converge over here, converge on the negative charge. They will just converge on the negative charge like this. Now if you understand whatever the previous system they have given, no. So I have converted the previous system into what? I have converted the previous system into, the previous system is basically a point charge and a conductor which is grounded. Now I am telling it is equivalent to what? It is equivalent to a plus q charge and minus q charge symmetrically kept about what? Symmetrically kept about the conductor. Let's say this distance to be d. Let's say this distance to be what? D. Now as I already said, this is an equivalent system. Whatever the previous original question that is given, now that original question is completely transformed. Actually they asked, what did they ask? They asked us to find, let's say, what is the force between the conductor and the charge. So it's like action-reaction pair, right? So it should be like, according to Newton's second law, it should be like Newton's third law, action-reaction, same amount of force should be there. So instead of finding what force it is applying on conductor, let's say I'll try to find what force the conductor applies on what? This charge. But that I cannot find because the conductor is non-uniformly distributed. But by using uniqueness theorem, I was able to find a setup where the same equivalent system can be created, and the system is what? A plus q charge and minus q charge replaced by a distance of what? 2d. So therefore, what is the force on this q charge? What is the force on the q charge? So simply Coulomb force, if I use k, q1, q2, just magnitude I am bothered about, kq square by what? Kq into q, kq square by 2d whole square. Kq square by what? 2d whole square. So which is nothing but kq square by 4d square. Kq square by what? 4d square. Kq square by 4d square. So this is the force acting on this q charge due to this minus q charge. Then again you might be thinking, sir, this is not the case that they have asked. But as I said, it's an equivalent system, right? That's what we'll be doing in R equivalent and finding C equivalent, or like whatever the like L equivalent, all that stuff. Equivalent means what? The same system, like the system which can produce the what? Same results of the original system. Now, whatever the original question is there, that I have transformed into a different question. So that's it. So this is the force acting on this q charge due to this minus q charge. So now I am telling this is the same force that the conductor will apply on this charge q. Right. So I hope it's clear. Now they can ask one more important question, nice question, that is they can ask you to find what is the energy that is like being stored over here. Okay, how much amount of energy that is like being present, or like interaction energy between this q and this one. Again, it's not a like point charge then that you can write simply, sir, I know what is the electrostatic potential energy between 2 point charges kq and q2 by r. No, you cannot write it because it's a non-uniform charge distribution, and yeah, so it will be difficult for you to like find. Okay, then sir, how to solve this? How to solve this means, see, again I know the, like as I said, actually the question that I asked is different, but as I said, the system is completely equivalent to this. I know energy for what? Energy for the new system, new equivalent system. Energy for the new equivalent system. I know what is the energy for the new equivalent system. What is the energy for the new equivalent system? K q minus q, k q and q2 by what? R. So R is what? 2d. So this is the energy. So which is nothing but what? Minus kq square by what? 2d. This is the total energy for the system. But you need to understand, actually speaking, when this conductor and like this charge is there, you need to understand the electric field exists only in which side? Left side. You need to understand there won't be any electric field over here. Okay, when the conductor is grounded, you need to understand there will be electric field only this side. There is no electric field on the other side. That means you need to understand there is an infinite plane. Here there is a point charge. The electric field lines are existing only on like one half. Imagine that this entire part is not there. This is how it should be there, right? That means energy will be stored in the space in the form of what? Electric field. So if the entire like this plus q and minus q charge is there, if all the electric field lines are there, in the entire space energy stored is this much. In the entire space, okay, because of this plus q and minus q, the energy that is stored is this much. But now the field lines are distributed only in one half. Okay, perfectly symmetrical. So therefore, what is the conclusion? Therefore, the interaction energy between Q and the conductor. Q and the conductor will be how much? Half of the total energy, U by 2. So that means answer will be how much? Minus Q square by 4D is the answer. Okay, so this will be the interaction energy. And they can ask one more very interesting question. What is the other one more interesting question? They can ask you to find, what is the charge that will be induced on the conductor. Okay, so it's an interesting question. So you should be able to tell what is the amount of charge that can be distributed over here, or the final charge that can be present over there. So what is the final charge that will be there? Final charge that will be there on top of this one will be obviously this minus q itself. Right? It's uniqueness theorem, right? The same charge I am just keeping it over here. So even if you try to find integrating whatever the non-uniform charge distribution is there. Okay, so final result that you are going to get is total charge on the conductor will be what? Minus q. And again one more very good question they can ask here. What's the one more good question that they can ask? They can ask you to find. They can ask you to find. What is the charge distribution? Okay, like how the charge is distributed. So, or like what is the like where the charge distribution is maximum, and all this stuff they can ask. Okay, so how to find like the charge distribution? Imagine this is the infinite plate over here. Okay, here the charge is, let's say, the perpendicular distance. This is, let's say, perpendicular distance is given as what, d. Okay, basically, like I know what is the formula for net electric field, right? Whenever I have, this is a conductor, right? This is a conductor. Let's say I wanted to find electric field on the plane, this plane at a distance of, so basically let's say this is z axis and this is the plane in which x and y axis are there. So let's say, see, this is the planar axis I am taking. Let's say this is this one is x axis and this one is y axis. So when you do x and y, z should be like what? So this is our z axis. Okay, imagine there is a random point over here which is, let's say, x comma y, which is x comma y, and obviously z coordinate is 0, right? So the point that I am writing over here, let's say x comma y comma 0, and this point, what will be the point on z axis? 0 comma 0 comma what? D. 0 comma 0 comma d. Now you know that I can find what is the field due to this over here, and due to minus q the mirror image will be there. So obviously you know the net electric field will be in what direction? Because of plus q, okay, because of plus q it will be like this, because of minus q it will be like this. Net electric field will be in what direction? Downward direction. Okay, like this. Downward means this is the downward, because I am watching the diagram from the side view. So obviously the net electric field should be downward, perpendicular in what direction? Downward direction. And as I said, it will be double the component. So basically I will be finding the electric field over here. Okay, the electric field over here, and then I need to take what? Then I need to take the component over here. Okay, basically let's say, therefore net electric field will be how much, you know? So first let me find E. Let me call this point as what? P. So the net electric field will be equal to K 2 times. So due to just a point charge I am writing, KQ by R square. R square is how much? X square plus y square plus d minus d whole square is what? D square. This is the electric field. But this is the electric field due to just what? Q charge. But if I want to find the net electric field, as I said, what you need to do? From here you need to do like this. Okay, it will be there at some angle, and you need to take the what? The component which is perpendicular to that. That means you need to take cos component. Okay, if that angle made with the vertical is theta, then net will be how much, you know? 2EQ cos theta. Net will be equal to what? 2EQ cos theta. Once you get this net electric field, so you know, like to what value you can equate this net electric field? To what value you can use this net electric field means, again, you know, one more important result from electrostatics for a conductor, you know, whatever might be the shape of a conductor, you know, the field just outside, right? Let's say here there is a Q point, electric field Q that is just outside, outside a conductor. What is the value? Just outside the value conductor is nothing but what? Sigma by epsilon naught. So therefore, I equate this sigma by epsilon naught to what? Sigma by epsilon naught to whatever the value I got, 2EQ cos theta I got, right? I'll equate it to that. And by this way, and you can clearly see that, okay, one second, here I have done some random question. So and you can clearly see that this, whatever this EQ is the electric field with this Q charge, depends on what? X and Y. Okay, that means at what distance it is there and what angle it is there and all this stuff. And so that means clearly you can see that sigma we got as a function of what? X comma Y. That means you need to understand the sigma is going to continuously vary from where to where. From this point, like considering this as center, so it will be depending on, so you can tell what type of charge distribution you will be getting, like circular uniform charge distribution will get. Circular uniform in the sense, for that circular strip the density will be uniform. Why? Because it's like you're getting x square plus y square, no? That x square plus y square, like for all the points which are at equal distance x and y coordinate, that x square plus y square, it will just form a circle, right? X square plus y square equals some constant. So like circular strips of uniform charge distribution will be formed, okay? And if you integrate the complete thing, if you integrate the complete the charge distribution sigma for the entire surface, then you are going to get this what? Then you are going to get this minus q charge. Okay, then you are going to get this minus q charge, whatever here it's there. Now here they can ask one more nice question. They can ask at what point the density will be maximum and what will be the maximum density. Okay, at what point the density is maximum and what is the density? Obviously the maximum density will be there when denominator is minimum. Okay, so fifth one, like they're asking what? Maximum surface charge density. Maximum surface charge density. Okay, maximum surface charge density. So how to find maximum surface charge density? As I said, this sigma will be maximum when this EQ is maximum. This EQ will be maximum when this denominator is what? Denominator is minimum. For what value the denominator will be minimum? Obviously, the like this is squares. What is the minimum value for a square? 0. So x and y are 0 means basically it's like the what? The perpendicular drop point. From the point charge, whatever the perpendicular drop point is there, right? There the density will be what? Maximum. So how to find the density over there? Let us find the net electric field over there. So what's the net electric field? Can you tell? Net electric field is, it is at a distance of what? D. So because of plus charge and minus charge, it will be doubled. 2 into kq by what? 2 into kq by what? D square. 2 into kq by d square. This electric field I'll equate it to what? Sigma max by epsilon naught. I'll equate it to what? Sigma max by epsilon naught. So 2 into 1 by 4 pi epsilon naught into q by d square, which is equal to sigma max by epsilon naught. Then this sigma naught will get cancelled. So therefore the maximum surface charge density, sigma max. So what is the value I will be getting for sigma max, sir? Sigma max I will be getting it as what? Q by 2 pi d square. So this is the value of maximum surface charge density I will be getting, right? And here also, as I said, by just substituting the value and taking cos theta, you guys can find the sigma as a function of like what? This coordinates x and y and all that stuff. Okay, so I hope this is like pretty much clear to you. So I have tried to explain all the like what different possibilities that they can be asking on this question. Okay, so if you want, I can create one more like good question based on this concept. Okay, but I am not going to solve it now. You guys can just think about it and you guys can try. Okay, and if you can find the answer, you can just drop it in the comment box. Okay, try to answer this. Okay, I'll just check the answer and I'll see if anyone can find the answer for this one. So now let's say there is an infinite plate like this. Okay, there is an infinite plate like this, and I'm telling that here I am keeping a ring. Okay, ring parallel to this, whatever the ring that I kept is, ring is parallel to this infinite sheet. Ring is parallel to this infinite sheet. Okay, now and I have given some q charge for the ring uniformly, and this ring got a charge of what? Q, which is uniform. Q, and this is what? Uniform. Now the question is, okay, so and this is a conductor. This is an conducting plate. Infinite conducting plate. This is an infinite conducting plate. And now the question is, you need to find what is the potential at the center of this ring. So here the question is what? Very interesting question. If you want, you guys can try. So the question is, find the potential at the center of the ring. Find the potential at the center of the ring. Okay, so I just wanted to give one more question on top of this. Okay, this one also you guys can try. So the second question that I'm going to give, that is also like very much interesting one. Okay, but within the JEE syllabus, if you stick on to within the JEE syllabus, then believe me, you cannot find you won't be able to solve the question that I am going to give. Okay, this one you might try. Okay, but the second one it will be little tough for you to do. Okay, so unless you go out of the box. Okay, this one also you guys can try. If anyone can get the answer, I'll be so happy if you'll be able to solve it. Just keep it in the comment box. And or else let's say you want the solution. Okay, you want me to do the solution, that also you can just request me, so I'll try to do one more video. Okay, on that to explain the solution of that, what are the questions that I have given. So it's already, the video became like so long, so that's why I'm not explaining these questions, so you can just try. So the next question that I'm giving is, this one is also very interesting. So let's say there is an spherical conductor and which is grounded like this. Okay, spherical conductor is there, and here I kept a charge q, and then you guys know on this one charge will be distributed non-uniformly. Okay, charge will be distributed non-uniformly in such a way that, sir, how it will be like, and I have given the conductor radius is r, that I have given, and I have also given, let's say this is kept at a distance of d from the center. Let's say this is 0, 0, and this one I have given it as what, d, 0. Now we know that the charge will be distributed on this conductor in some non-uniform way, ensuring that what? Ensuring that this conductor will have a what? Zero potential. So obviously you can tell it will be a negative charge. Ultimately you will be getting a negative charge. Then only the potential can become what? Zero. Why? Because due to this you will get a positive potential, and for potential to become zero, obviously you should get a what? Negative charge. The negative charge will be distributed entirely on this spherical shell, but it will be completely non-uniform. Okay. So now you need to find what is the force between this one and this sphere, or whatever it is. I can ask what is the potential at the center. Okay, I can ask what is the potential at the center, or I can ask what is the interaction energy between these two. Okay, I can ask whatever the questions I asked earlier, right? Again, I can ask all the questions. What is the charge on the sphere? Okay, I can also ask you what is the charge on the sphere. That's also a very interesting question. Okay, so but within the JEE syllabus you won't be able to solve all these questions whatever I asked now, only if you go out of the box. Okay, so only if you're serious aspirants or preparing for Olympiad exams like NSCP or IPHO, then you should do this. Okay, you should be going out of the box, and you should be knowing all these concepts whatever I explained here. So again, see, it's randomly whatever the things that I'm asking, you just you can analyze yourself and try to find all the things. Simply you need to understand from the start of the concept whatever I told. So in the starting itself I told, if you are able to get an equivalent system, okay, when the charge distribution is non-uniform, when the charge distribution is uniform, if you are going to get an equivalent setup where you can just replace the entire thing with a point charge, once you get a 2-point charge, it's an easy setup for you, right? It's completely an easy setup for you. So whatever you want to find energy, you can find. You want to find field, you can find field. You want to find potential, you can find the field. If you want to find force, you can find the force. So whatever you want, you can find, right? So that means, so in this question, basically you just need to use again the method of images or uniqueness theorem, and you need to find a particular charge. Okay, you need to find a charge and the position of charge, ensuring that what? Ensuring that we are going to get an equipotential surface, just as what? Just as this conductor that is given. Not only just equipotential surface, and the potential of that must be what? Zero. That type of charge you should be able to pick, that unique charge, and that uniquely kept position you need to find, ensuring that what? Ensuring the potential in this entire, it is an equipotential surface. Potential everywhere here should be what? Zero. And here, as it is in finite shape, a spherical thing. Okay, so earlier I told we don't know the calculations here, I don't know how to find and all that stuff, right? But when the shape is this symmetrical, okay, it's like very beautiful shape, spherical, right, symmetrical in all the directions. So in this case I can find the amount of charge, I can find, and the position where the charge should be kept, that also I can find. Both the things I can find. And once I was able to do that, if I, after finding the charge and position, as I said, whatever might, like whatever you like, it can be asked in the question, we can easily find, right? So I hope it is pretty much clear. Okay, if it is not clear, once again go through whatever like I explained. Okay, and try to analyze the things on your own, so that you'll be getting more and more clarity. Okay, so even for me it took so much time to understand all these concepts. Okay, again, like some of the knowledge I got from like I referred one book called Purell. Okay, and like one more reference from where I have like studied and understand this concept. Like, see, there are like n number of resources and n number of books and like things that is available. Okay, so just having the resources is not just enough, right? So once you realize and once you analyze the things on your own, that's when you're going to like have that satisfaction or that like kick off, like understanding the concepts and all that stuff. So and HC Verma sir, like so like some multiple sources I have like gone through these concepts, and then it's not clear. Okay, so after that I like what did self analysis in all these concepts, and then I got an understanding how the things are working and how it is like happening. Okay, and so one more, like just before ending, I just want to tell one more small thing. So I guess you would have heard this important note point, or like very very common note point, that in books it will be written and the teachers we say, that is, whenever an uniform distributed spherical conductor is given, okay, or spherical conductor or spherical non-conductor, we'll say we can treat the entire charge kept at the center, right? So you remember that. That's a like important note point in electrostatics. Even for JEE mains also we'll use that point, right? Even for JEE mains, bit set, even for the smallest exams also we'll use that note point. That is, whenever a uniformly distributed spherical conductor or like non-conductor is given, to find anything outside the conductor or like non-conductor, we'll assume that entire charge is kept at center, no? So what is that? From where we have got that? So from where we have got that? Again, so there, like the answer is uniqueness theorem. Okay, so like again you are going to get an equivalent setup, that is like keeping that entire charge at the center. Okay, we are going to get the same results. Sir, how? Because like how means like again, whatever the starting theory that I told, you can just like from there you can understand this point charge will ensure that you are going to get same kind of like what, same surface, whatever the like same surface as the what conductor that is given, which is equipotential, and it should also like ensure that what, the potential should be same, whatever the potential that is there. If it is grounded, the potential should be what, zero. Okay, so that is the reason, again from the uniqueness theorem, and like uniqueness theorem only, you will be telling that the entire charge, okay, can be placed at the what, center, because it is also giving the same results as that one, and that is the only like thing that is possible, that is uniquely possible, and like there is no other thing that is possible, and that's what the unique theorem states. Okay, so I hope you understood and you like the concept. Okay, thank you, bye bye, enjoy.